Let's go with the setup. And this is the DIN connector. You have to connect the DIN connector to the kit. So we have switched on the kit. Here you have a power switch actually. Okay, have to switch on the device, optical fiber kit, and this is the initial state of the kit. Okay, so we have two different modes here, analog and digital. We are going to discuss about digital link. Okay, so I am switching the power to the digital state. I'm going to connect the optical fiber cable here. You're going to use 650 nanometer range. Okay, and in the receiver section we have pin diode, just a photo detector. Okay, it will generate current in direct proportional to the amount of light incident on it. Okay, so we have here is just a PLL generator. Okay, to generate pulse width, that is square waveforms, and this is what the digital setup is all about. We have a transmitter section, receiver section. We have connected the transmitter and receiver section with the optical fiber cable, 1 meter cable, and this is a multimode fiber as we discussed. Okay, and we are using 650 nanometer range. Okay, so what we have to do is we have to verify whether this 8 bit of data is transmitted to the receiver section, and I am going to change the gain. Let's set up any bit here, a test bit here. Okay, and this is actually positions. Okay, 0 to 8, 0 to 7, we have here 0 1 2 3 to 8. Okay, I have highlighted 5th, 3rd, 2nd and 1st bit. Okay, and this is actually a gain knob. Okay, in order to vary the pulse generated by the TTL generator. Okay, and I am varying from minimum. Initially it is at minimum position. Okay, I am going to move to the maximum region. I am slowly varying the knob, the gain factor. Okay, so what we have here is we have successfully transmitted certain test bits to the transmitter section. Okay, you could be able to check whether the bits you are transmitting is promptly received in your receiver section. You can vary the input bits and you can check. Okay, whenever I switch off this, you could be able to see this change, right? I'm switching on the first switch, and here you are receiving the first bit. Okay, so this is a digital link. Okay, this is all about digital link, and next we are going to discuss about analog link. Okay, as we discussed, this is our digital link. Okay, so we have here the output can be retrieved through this BNC cable. Okay, we're able to see the pulse waveform, the I patterns of our digital transmitted signal. Okay, so while varying our input bits, if you are varying the input bits, could able to see the difference. Okay, the I pattern, that is each one represents a bit. Okay, this each pulse represents the bit transmission from the transmitter to the receiver section. Okay, this is our analog optical link. Okay, this setup is to establish analog link from transmitter to receiver section. Okay, what we have did is we actually have in our digital communication, just we will connect this optical receiver to the input section, right, in order to measure the waveforms. What we have included in our analog link is we will be feeding a separate sine signal. Okay, from a function generator. We are feeding the sine signal from the function generator to this particular IO1. Okay, I am connected a sine signal to this IO1, and from this IO1 I am feeding to this, as we discussed, section. This is our digital link. Here is analog input, and so I have switched we have here the output can be digital mode to analog mode retrieved through this BNC cable. Okay, we're able to see the pulse waveform, the I patterns of our digital transmitted signal. So the waveform is like, so while varying our input bits, this is our actual output. You are varying the input bits. So this is the output we see the difference get from the analog transmission. We will be getting the as such transmitted sine wave. Each one represents a bit. Okay, this each pulse represents the bit transmission from the transmitter to the receiver section. So this is all about the analog and digital transmission link. Okay, we have successfully established the digital link as well as the analog link. The only change from the digital to analog is that we will be including external input sine wave signal in the analog link, and we will be using the internal clock signal in case of digital link. Okay, hope you would have understand the experiments. Thank you.